This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount. Hi, and welcome again to another video. Today we're gonna learn how to design an electronic resistive load to 50 amp originally made by electronic circuits. So this board is capable of withstanding an initial load for low voltage sources 4 volts or 40 amps, and for voltage above 5 volts, current is 50 amps supporting voltages up to 45 volts. So let's start designing it in Altium Designer. So first, you should have a PCB project file. In order to create a PCB project file, just click on File, New, then Project. Then the Create Project dialog box will appear. Now, this is where you can set the project name and the folder in where you want to save your project. So let's put here Electronic Resistive Load for the project name. Then, click Create. After you create a PCB project file, next we're going to create the schematic doc. Click again on File, New, then Schematic. Then save this one. Next is for the libraries. Click again on File, New, Library, then Schematic Library. Save it again. Next, PCB Library. File, New, Library, then PCB Library. Save again to the same folder. Next, go back to Schematic Doc. For this case, we'll be using a library loader. So this is the Altium library loader, and we're just gonna copy the manufacturer part number of each component into the search tab, and it will automatically load in our schematic doc. So this is the BOM list for this project, and here are the part numbers of each component. So we're just gonna copy each part number to the library loader for us to generate each library of this component. So let's try this one. Copy the part number for terminal block, then open the library loader, paste it to the search tab, and click on search. Just wait for it to load. So here are the results. Just click on it, then click Add to Design. As you can see, it automatically loads in our schematic sheet. And if we go back to the schematic library, you can see that it is added on the library. Now repeat it in all components in the BOM list until you finish all the libraries. After you finish all the components in the BOM list, here you can see in the schematic library panel all the components that added on the library. So for this case, I manually edited the comment to put the value and the package of the component. So if we are going to place it in the schematic sheet, it is much more readable. Next thing we need to do is to add all the components in our schematic sheet. Just go to Components panel, then you can see here are the libraries. So just drag it inside the schematic sheet. Next, we need to assign designator on each component. So it can be edited manually by double-clicking the components, and here you can set the designator. And we can do it also in automated way. Just click on Tools, Annotation, Annotate Schematics, then click on Update Changes List, click OK. Now you can see in the proposed column the assigned designator for each component. So click Accept Changes, Create ECO. Then click on Validate, then Execute Changes. So close all this dialog box, and now you can see the designator has been assigned to all components. After that, we're going to put the connection on each component. To add connection, click on Place, then Wire. Now click it to the pin of the component and snap it to the other end of other component in where it should be connected. After that, we'll put a power port for the ground. So just click on place, power port, then snap it to the connection. Now this is the finished schematic, and since we have a small circuit, we will adjust the size of our schematic sheet. Click on Properties, then change the units to mm, click on Custom, and this is where you can set the width and the height of your schematic sheet. Then set the margin and zone to 2 and 2. And now we're done with the schematic. After that, it is important to perform validation before component placement. So to validate the schematic, just right-click on the PCB project file, then click on Validate. To see the results, click on Messages, and as you can see, no errors found. After that, we're going to start the placement. So first, we need to create a PCB. Click on File, New, then PCB. Save this one. Then after that, go back again to Schematic Doc and perform Engineering Change Order. Click on Design and Update PCB document. So the Engineering Change Order dialog box will appear, and these are the nets and components and classes that we'll add on our PCB. Next, click on Execute Changes. As you can see, all the components from schematics are added here in the PCB. So we can start the placement. Just drag the components inside the PCB. After we put all the components inside the PCB, next thing we need to do is adjust the board shape. In order to adjust the board shape, press 1 on your keyboard to activate this kind of view, then click on Design, then Edit Board Shape. Now you can see a snap points appear, so we're just gonna manually drag it. Then press 2 on your keyboard to go back on the previous view, and now as you can see, here's the board shape. Now we can start with the layout. Now to put connection on the pads, click on Route, then Interactive Routing. Just click on Path and snap it to the other end of the pad to where it should be connected. Now we're done with the layout. Now to view it in 3D view, just press 3 on your keyboard. Now we're done in designing an electronic resistive load. So, I hope you learned something from this video. Thank you for watching.